Lesson 3 is interpreting graphs, and we're going to interpret information given in a graph and make a graph to actually model a situation. We have two kinds of graphs that we're going to look at. The first is a continuous graph, and that's a graph that's made up of connected lines or curves. So in some cases you'll plot the points that coincide with the information given, and then you're going to connect the lines or make a curve. And then we have a discrete graph, and that's just a graph that's made up of distinct or unconnected points. It wouldn't make sense in this situation to connect the points, and we'll go over each type of graph in just a few minutes. So here, for example 1, it says the graph shows the speeds of 2 cars over time. Tell which graph corresponds to each situation. So here we have time in the horizontal axis and speed. And so it looks like the speed is staying pretty consistent on this first one, and then as time increases, the speed is decreasing a little bit fast, and then it slows down. It still looks like it's decreasing, but it's slowing down, and then it's decreasing more, and then it comes to a stop. The second one looks like the speed is going pretty fast, but it's coming to a stop, and then it picks back up again pretty fast. So let's look and see which one goes with each situation. Mr. Lee is traveling on the highway. He pulls over, stops, and then accelerates rapidly as he gets back on the highway. So we have to decide, is that graph 1 or graph 2? So he's traveling on the highway, so he'd probably go pretty fast. So probably not just a steady speed right here. He's going pretty fast because it says he's traveling on the highway. He stops and pulls over, so it's going to be flat, and then he accelerates. So this is actually going to be graph number 2. And the explanation again is the speed decreases until it becomes 0, and then the speed increases. So the next one obviously has to be graph 1, but let's look at it. Ms. Montoni slows down as she leaves the main road. So here she is, she's leaving the main road, she's slowing down. She continues to slow down as she turns onto other streets and then eventually stops in front of her house. So this is graph number 1. The speed is constant, so it stays the same, and then the speed decreases at various rates until it finally becomes 0. All right, let's look at the next slide. They want us to create a graph for each situation, tell whether it's continuous or it's discrete. The table shows the temperature inside a car over time. So we need to go ahead and create an XY axis, and I'm going to pause it right here so that I can do. Okay, as you can see, I've drawn an XY axis, and my x-axis is going to represent the time. My y-axis is going to represent the time, or the temperature, in degrees Fahrenheit inside the car. My time has to go from 8 o'clock to 12:30. So I can just go ahead and do little half hours at a time, but I'm going to break the scale and go 8 o'clock, 8:30, 9 o'clock, etc. 9:30. So I went from 8 o'clock to 12:30 down here in equal intervals, and again I broke the scale. And for my temperature I have to go from 71 degrees to 82 degrees. So again I'm going to go ahead and break the scale, and I will just go 70 degrees, and I'm going to go by twos. So 70, 72, etc. Okay, now I'm going to go ahead and plot the points. So at 8 o'clock the temperature in the car was about 71 degrees. At 8:30 it was still about 71 degrees. At noon it was 82 degrees, so here we are clear over at noon, 82 degrees. And at 12:30 it dropped back down to 74 degrees. And we have to decide if this is continuous or discrete. If it's continuous, it means that we would go ahead and connect, which means that there's going to be temperatures at different times of the day. If it was discrete, then it means that there's only a temperature inside the car at 8 o'clock, 8:30, 12 o'clock, and 12:30. So this one is actually going to be continuous, because we know that you still have time, or you still have a temperature at all these different times. So we're going to go ahead and connect. The points. And this is actually, I don't know if it's going to end up being a curve like this. It just happened to be a curve the way that my pen worked. So this is continuous. So we need to write continuous. Okay, and then down here we'll just uncover these. It says, since every value of time has a corresponding temperature, we connect the points. And again, like I said before, the graph is continuous. Okay, let's move on to the next one. Okay, the next one, the situation says a market sells pumpkins for $5. So we have to go ahead and create a graph for that. So let's go ahead and draw our XY axis again. Here, our x-axis is the number of pumpkins and the y-axis is the cost. So we're going to go, one pumpkin is $5, 2 pumpkins would cost us $10, 3 pumpkins would cost us $15, etc. 4 pumpkins would cost us $20. So when I'm plotting the points, this is what I'll end up plotting. Now again, we have to decide, is this continuous or discrete? Would it make sense for them to sell us 1.5 pumpkins or 2 1/10 of a pumpkin? It does not make sense for us to connect these dots, because if we connect it, then all the points that are along the straight line here would be they'd have to have a solution. And again, you're not going to find anybody at a pumpkin patch is going to sell you 3 3/4 of a pumpkin. So this is actually going to be discrete. So we have the cost, which is the y-axis, increases by $5 for each pumpkin purchased, which is the x-axis. Because each person can buy whole pumpkins or none at all, the graph is distinct points. So the graph is discrete. The graph is discrete. All right, I'm going to have you do the last few on your own and bring them in done tomorrow, and we will discuss them with your AB partners. If you so choose to start your assignment early, you're welcome to. This is lesson 3, chapter 2, so 2-3, page 61 to 63. Numbers 1 to 22.